Hi everyone, welcome to my channel. This is a redo of a video I did in the past. Someone's requesting a little bit more detail, I guess, because they can't get it to work. I've had comments before that videos gone too long. And you forget yourself when you're trying to present something, something that might be obvious to you is not going to be obvious to someone else. You forget what it was like when you were first starting and you didn't know much about this either. So this is the circuit, and I've got it up and running again. The orientation's a little bit different, but the idea is that we've got an LED that's constantly on, the green. In the other video, the green was on the top. And we have a momentary switch here. You have to keep pressure on it to keep it closed. I've added another LED here to show what happens when you press this in. But when the switch is open, this is the state of the LEDs. When it's closed, when you press this button, the green light goes off, and then these two red LEDs flash alternately as long as this button is pressed. So you can see there the action of the LEDs, and it goes back to the green constantly on and the two LEDs off, the two red LEDs. I added this here. I was just trying to highlight the fact that when you press this button, the 5 volts now gets a path to the other side of the pin here on this switch. So I just have this LED going from the junction of this switch connection here through a resistor, to the LED through a resistor to ground to limit the current. So that just shows you each time that LED is pressed. And this action here, of course, is accomplished in the sketch that is written and then uploaded to the Arduino. So I guess I'll tear this all apart and then we can go from scratch. Let's take a look at the schematic. So here's the Arduino Uno. And we want to, first off, we have a 5 volts that we have to connect to one side of the switch. And then the other side of the switch has to go to a 10K resistor. And then the other side of that 10K is connected to ground. And we're using the ground off of the Arduino Uno over to the breadboard along with the 5 volts that we bring over to the breadboard. And we're just using the digital pins, which can be designated as either inputs or outputs, because we're going to designate pin 2 as an input, and it's either going to see 0 volts or it's going to see 5 volts. It's going to see 5 volts when this button or when the button on the switch is pressed in, and it shorts those contacts out, giving a path of the 5 volts to this point here. And we'll be reading that digital input. Pin 3, 4, and 5 are going to be designated as digital outputs, and they will be connected to the anodes of 3 LEDs and then the cathode of each of those LEDs. In my case, I found a 330 ohm resistor, so we'll take these, and these, we'll change them to 330 ohms, like so. And then those all go to a ground connection. So pin 2, depending on whether we see a 0 or a 5, we're going to write code that says when we have a 0 volts on pin 2, we want the green LED to be lit, and we want the two red LEDs to be off. When we press the switch in and we then have a 5 volts, when we see 5 volts on pin 2, we want the green LED to go off, and we want the two red ones to alternately flash on and off. And that's all accomplished in the code, in the sketch that we upload to the Uno. So let's redo the wiring. So let me disconnect this. Let's take out these 330 ohm resistors. This was something extra that I added. Got the LEDs, which I'm thinking, I don't know, orient them the way they were in the first video. We've got this, disconnect everything. So we can go over the methodology, how we approach this. Okay, even take the very last one. So here's the bare breadboard with the Arduino. So the first thing we want to do is we want to have access to the 5 volts and ground on the Arduino. So you can see here, there's two ground choices. Here's a 5 volts right here. Make sure you're in the right spot. Bring that over to the plus rail here. Doesn't matter. Right, put right there. So what that does is it now, this whole column here, all the way down, is all connected together. So we now have access to 5 volts in any one of these holes. We can bring over to the breadboard over here with another wire, or stick the component directly in there. And now also the ground. So ground is right next door here, and we'll bring the ground over right here. So now the negative, that's all ground access. Now I also want to extend this ground point over to this column here, because I want to be able to connect to ground over here. Just made the circuit a little bit neater. Now here is my switch, and you can notice I've soldered some wires onto that. Where's the other switch I had? The switch on its own, the connections are sort of short. They tend to pop out of the breadboard. It's doable, but it just makes it a little bit more convenient. So if I left my meter on, have to make sure I orient this switch correctly. So if I measure here and then put my meter on this buzzer for check to continuity, when I press, this will buzz, and I'm shorting out these two connections. So connecting one side to the other. So that's how I want that to be oriented. I'm going to put that up here. And I'm just going across the channel here, but I'm only going to use this one side. So what I want to do is, if we look on our schematic, one side of the switch goes to plus 5 volts. Now the other side will not see that 5 volts until we press in this button and keep it pressed in. So from there, we want to go to a 10K resistor, which is brown, black, orange. So we can go from, we just put the resistor in this side. This whole row here is connected, that the pin from the switch, the other side of the switch is connected to, and just have the other side of the resistor go to ground. And We've now completed, we can see here. So we now have the plus 5 volts going to one side of the switch and the other side of the switch connecting to this 10K resistor to ground. Next, we want to take the intersection or the junction of those two connections, the 10K and that switch, because we're going to be looking at that voltage right here. We're going to look at that with pin 2, that we're going to read that voltage with a digital read over here to pin 2. So we have RX, this is pin 0, TX pin 1, and pin 2 is right there. So that will be specified in the code. So now we have that hooked up to pin 2. Now we can work on the diode. So I'm going to change this around to what it looked like on the original video. Now if we look at the diode, at the LED, let me just put that in here. Let's get up close. Not that close. So actually that's difficult to see. Can you see? There's a little bit of a flat on the left-hand side there. That is also the shorter lead. That is the cathode. That's got the line on it, on the symbol for an LED, and also a diode. Oh, that's more discernible right there. That line indicates how you want to orient this. And if you haven't previously cut these leads here, the shorter lead is the cathode. So the anode you want facing toward the digital right pins that you're going to designate in the program, because you're going to make that either go high or low, and if it's high, then this LED will turn on. The cathode, or the shorter lead, is pointing toward the ground through the resistor. So we'll take this LED and plug it in here with the long leads on the left and the short leads on the right. And it really doesn't matter what side you put this resistor on, but we'll put it on the cathode side. So from there, we'll go to ground that I've extended over here. So there's the green LED, and also the anode. Do I have that oriented right? Yeah. The anode, right here, we'll use a red wire, goes to pin 3. So let's hook that up to pin 3, right next to pin 2. There, that's the first LED. The next red LED, again, with the short lead on the right and the long lead on the left. Plug that in. Again, I'm using a 330 ohm resistor from the cathode to ground. And then we want to go from the anode over to pin 4 on the Arduino. And then we can take the next one, again, with the flat portion facing to the right, and also the shorter lead and the longer lead to the left. We'll plug that in. And again, a 330 ohm resistor from the cathode to the negative, or ground over here. I've extended from the other side here. And then the anode, the left side goes over to pin 5. Now what I did is so that's the 3 LEDs. I just added one over here. I wanted to show that the 5 volts appears on the other side of the switch. So I just have that plugged in there. And again, I have another resistor going over here to ground. Let's back off of that. So other than that extra LED, this is what the circuit looked like. So I take this and I plug it in. There's the green LED on again. And when I press this button down, the green LED goes off, and the 2 red LEDs light, alternating or toggling back and forth as long as I keep the switch plugged in. So that's the wiring for that circuit. So hopefully that'll help some people wire this up if it wasn't clear in that other video. There are some clues, or there is information that you can get out of the sketch, because in the sketch you have to designate the pins that you're using for digital read and digital write. And we're using the digital read, we're using pin 2. So that's being defined in the sketch. So that told you that we're reading using pin 2. We're reading the voltage on the switch, and also digital write on 3, 4, and 5 is telling you that those are the pins that we're connecting to the LEDs. But you know, you can stop it here. I guess I'll go on real quick and type up the sketch, and you can watch the process, how we enter in the sketch into the Arduino IDE and then upload that to the Uno. Otherwise, you can just stop it, and if you already feel that you successfully know how to enter in the code. So this isn't ideal. I just have the camera pointed to the monitor. I've opened up the IDE, the Arduino IDE. You can see here we have some initial functions and a couple of comments, and it's named the sketch. But here we have void setup function and then a void loop. What we want to do is, let me enter in a couple of returns here. We want to initialize a pin. So we're going to initialize a variable. We're going to call a variable designated as an integer. We'll call it switch state, and we want that equal to 0 and semicolon. So integer switch state equal to 0. You put another space on the other side of that equal sign just for readability, and then click into the void setup function here. I'm going to take out this comment, and we want to define all of our pins as inputs or outputs. So we do that using pin mode. So we have pin mode, and we're going to say 3 is going to be an output, and using pin mode again, not pint mode, but pin mode, we want pin 4 to be an output, and we want pin 5 to be an output. So pin mode, pin 5, output, and finally pin mode, we want to designate pin 2, this time as an input. That's what's going to be looking at the voltage on the switch when it is closed. So we've defined all the pins that we're going to be using. Make sure we have our closing bracket here. And now we want to click into the loop section. The loop function, take out this comment, and this is where we are going to say that we're going to use digital read pin 2 that we've called an input, and we're going to take that measurement and store it in the variable that we initialized calling switch state. So here we have switch state that we've already initialized and defined, and we want to say digital read pin 2, that's connected to that one side of the switch, that's going to read either a 0 voltage or a 5 volts. And it's going to take that and store it in the form of a binary 0 or a 1 in the variable switch state. Now, what do we want to do with that information? We want to make a decision based on that value that we store in the variable switch state. So if switch state is low, is equivalent to a digital low, which is 0 volts, we're going to want it to do something. So what is it that we want it to do? We want the low state to say that the green LED is on and the 2 red LEDs are off. So we're going to digital write to those pins that we have those LEDs connected to, and we're going to write either a high or a low to them. And what we said is we want to do a digital write pin 3 that is connected to the green LED. We want that to be on, so we have to put a high on the anode because it's already connected through the 330 ohm resistor to ground. All right, we want that high. And then digital write pin 4, we want the next two LEDs, the red ones, off. And you do that by putting a low on the anode of those two LEDs. So now we do digital write again, and that's pin 5, and that's a low again. So you can see there that says that green high is going to be on, and the next two on 4 and 5 are going to be low, and they'll be off. So then what do we want? Well, we said if. We said if the switch state is equivalent to a low, do that. Else means if it isn't low and we press that button and it's a 5 or a 5 volts or a digital equivalent to a 1, we want it to do something else, and that something else is turn off the green light and toggle the two red LEDs on and off. So now we say else. Else, what we want to do is digital write. Now we want to turn the green LED off, low. I have to adjust the camera again. Oh, can you see that? So you can see there, I have switch state equal to digital read 2. If switch state is low, digital write 3 high, digital write 4 low, digital write 5 low. Else, digital write 3 low and digital write 4 low. Now you might say, well, how come we're not saying 4 is high and only 5 is high? That's not incorrect. Well, it'll become clear in the next bit of code. So digital write 5. Now we are going to say high. Now what happens is, if we don't put a delay in, you won't be able to see the toggling. It'll just look like they're both lit at the same time, but a little bit dimmer than usual. So we want to say delay. We'll use the function, and we have to enter in a value there. We'll pick 250. And we want to toggle the LEDs. So we've already turned on the LED, the red LED that's on 5, and 4 is low. And now we want to switch it up. So we're going to say digital. We only have to say digital write. We don't have to tell the green LED to do anything again. So digital write. And now we're going to reverse it. So we're going to now say 4. We want to go high. And digital right? On 5, we want to go low. So see, we've switched them now. But if we didn't put that delay in there, you wouldn't notice them toggling. So now what we want to do is put in another delay. And all of this is in a loop. So it's constantly looking at the voltage on pin 2 and making a decision on how to light these LEDs in a constant loop in this particular program. So there's the last of the delay. Make sure we have all the brackets paired up so we don't have any that are odd, opening and closing bracket. And I think I have everything, and I'll quickly find out. Do I need to go down here lower again? Okay, so you can see there that we digital write so that 4 and 5 is low and high, and then we did a delay, and then we did the opposite. So we have a digital write high and a digital write low on 4 and 5. So we did the opposite. That's what gives you, and with the addition of the delay, that gives you the toggling effect. So that's with the previous successful upload. So let me go ahead now, and you will see these LEDs here flashing, showing that it is receiving the sketch. So upload, and it's flashing. So you can see there with the sketch uploaded, it's doing exactly what we programmed it to do. So with 0 volts, we have the green LED on pin 3 lit and the 2 red LEDs off. And when the button is pressed, the green light goes off and the 2 red LEDs toggle. So I hope that was helpful to that individual that asked about this, and I'm sure that there are other people that this will help clarify some things. And if you like this video, feel free to subscribe, like, and/or comment. And thanks for watching.